Alright, so with this shape, we're going to start with the basics by finding the area of the front face. Now the first question you got to ask yourself is, should I dissect the front face like this or the other way around? Now it comes with a bit of trial and error. When I did it last night, you actually want to dissect it this way. And let's find out why. Alright, so if I want to find, girls, the area of that front face there, we need 20 times that length. Yeah, how do I know that's 6?
16.
Yeah, because if you do 16, take away 10. See, if it's 10 there, it's 10 here as well. Yep. So 16 take away 10 gives you that. All right. So I'm going to start writing the working out. So surface area equals 20 times 6 plus then this area is 10 times, what's that? I'll do that in purple. Girls, if this whole thing's 20 and that's 12, that's right. So let me just label it just in case. So if that's 12, that's 12. So 20 take away 12 gives you that, which is 8. So that area is 10 times 8. Yeah? Now what I'm going to do on top of that, remember, it's the same for the front and the back. So I'm going to get this whole thing and I'm going to times by 2 for the front and the back as usual. Yeah? Yeah, surface area. Now, I need to add now this, let's find the area of the side. So when I mean by the area of the side, that and that. When you look at this actual prism from side view, obviously you won't be able to see that flat side. We're only going to be looking at that area of the side. Now the easiest way to find the area of both of these at once, girls, think of these two areas put together as one big rectangle. So I'll just, sorry, hold on. Can you see that both of those two shaded rectangles make just one big rectangle? Yeah, can you see that?
Yes.
All right, so girls, that's 15. But what's the length of that whole thing? 20. So the area of the side is 20 times 15, which is the same for the area of the other side. So I'm going to times that by 2. Plus, now let's do the area of the top. So the area of the top is the part shaded in red. Now can you see once again, if I just combine the two shaded areas, from the top view it's just one big rectangle? That's right. Okay? So that's right. That's 16 times 15. That's right. Good. So those are the little shortcuts that I want you to be able to do without finding each and every single faces. That takes too much time. Even just doing that is long. So let me just do that quickly. All right, let's say everything's in square meters. Let's start with this front here. That's a semicircle. Let's find the area of a semicircle first. So that we know, yeah, it's half of a circle. So half pi times, what's the radius? Yeah, half of 56 is 28. 28 squared, don't forget the squared. Okay, I'm not going to times by 2 yet. I want to find the area of this and the rectangle put together, then times by 2. All right? Plus the area of the rectangle is obviously 25 times 56. Now I'm going to times the whole thing by 2. Okay, for the front and the back. Yep. I'm going to now find the area of the curved shape of the semicircle. What was the area formula for just a curved surface of a cylinder? So remember last lesson how I said the surface area of a cylinder is, that's right, 2 pi r squared for the two circles on the top and bottom plus 2 pi r h for the curved surface. Because now we've got half of a circle, instead of 2 pi r h, it would be pi r h, just pi r h. All right? In this case, girls, what is the radius of the circle? It's still 28 times what's the height of this cylinder? Half a cylinder? 40. Yeah, can you see that? Yep. All right, so that's the top. Now let's find, what else do I need to find?
40 times 25.
Okay, let's find the area of this. 40 times 25? Oh, that's what you're saying. Yep. 40 times 25, and is that the same for the other side?
Yes.
Times by 2. What else is there?
40 times the base.
All right, the base. Yeah, we forgot the base. Yeah, don't forget the base. Yeah, so the invisible base that you can't see in the front. Yeah, anything else that I've missed? 1.6, let's just say centimeters. Yep. All right, last example, girls. Now, when you have an annulus on top, an annulus is when you got two circles put together in one. So what this diagram is you've got a hollow gap inside the cylinder. One fact that you need to be mindful, when you find the surface area, you actually need to find the surface area inside the hollow cylinder as well. So don't neglect the inside. All right, I know surface area is all about finding the area of outside only, but when you got a hollow gap, you need to find the area inside that hollow gap as well. All right, let's find the area of the top. Do you guys remember the area formula for an annulus? Do you know what an annulus is?
No.
Okay, so annulus is basically, when you got two circles, annulus is just the area between the two circles, and the quick way to straight away find the area of that is this. I'm pretty sure I've taught you this last year. It's just a big circle minus a small circle put together. I'm pretty sure you can see that from here. So if I just do that straight away to find the area of the top, all right, let's get into it. Surface area, pi times, what's my big radius? 20 squared minus 15 squared. Okay, that's for the top, which is the same for the bottom. Yeah? Are we good so far?
Yes.
Plus the area of the curved surface, which is outside here. Like I said, that's the area formula for the curved surface. So 2 pi h, which I'll do it in purple. 2 pi times, what's my radius of that big curved surface though? It's 20. Yeah? Times the height is 36. All right, we're almost done. That gives us everything on the outside. But like I said, you also need to add the area of the inside of the hollow cylinder. How do you find that? What formula will I be using to find the area of the inside of the cone? It's a curved surface. It's 2 pi h. The curved surface inside, it's 2 pi h. Do you see that?
Yes.
So if I use 2 pi h in this case, the inside cylinder though, the radius in this case is 15 times 36. Yeah? So what I'm trying to say is, don't forget to include the inside of the cylinder. All right, any questions?